For the next video, I want to show you how to find the confidence interval for the true proportion using your calculator. So we have here this example where we had a box that had 30 red beads and 90 white beads, and we want to be able to construct a confidence interval from that data. So we're going to construct a 95% confidence interval for the true proportions. We're going to use a formula, substitution, and final result. Okay, so the formula for a confidence interval for a true proportion is our point estimate, which is p hat, plus or minus, and then our critical value, z alpha over 2, times the standard deviation of the sampling distribution of sample proportions, i.e. the standard error of p, which would be estimated to be p hat times 1 minus p hat all over n. Okay, so there's the formula. It's in the notes, so back a ways, right here. P hat plus or minus that thing. Okay, so we need to, there it is. Okay, so we need to fill in all the parts. Okay, so let's take a moment and remember what p hat is. Matter of fact, let me put that somewhere else. So, note, p hat is equal to x over n, where x is the number that had what you wanted, your desired outcome, and n is the total. It's actually very much the binomial distribution, right? X is 30 in our case, right? That was, we had 30 successes, 30 red beads out of 120 total, right? Which would be 0.25, if I'm not mistaken. I will find out. 30 divided by 120 makes 0.25. Okay, so we have 0.25 as our sample proportion. So we're going to use that. And they won't always give it to you quite this way. Sometimes they might actually just give it to you directly and say, hey, it was 0.25. But in this case, we had to go find it. Okay, so then, oops, you go back up here. There we go. Okay, so now I want to use that information to find my lovely, lovely confidence interval. So I'll say 0.25 was my p hat, and then I want 0.25 here, and I want 0.25 over here. And then n was our sample size, which was 120. And then z comes from a confidence level. So we have a 95% confidence level, and we learned back here on this page that if you have 95% confidence level, your z alpha over 2 is 1.96. Okay, so that gives me here 1.96. Okay, so now I could go try to type that big honkin' thing into my calculator, but let's face it, you're probably going to mess it up. It's easy to make mistakes. So what I'm going to do is I'm going to grab my calculator. So stat, go to the right to tests, and we have a whole bunch in here that we're going to be using in chapters 9, 10, 11, 12, and beyond. We're looking right now for one prop, because prop stands for proportion, z int. This is it. One prop z int. Int for interval, prop for proportion, right? And 1 because you're working with a singleton. You're going to be working with 2's in chapter 11. So we're making a single proportion. We had 0.25. That's our only proportion. So we grab that one. And now it needs x, n, and 0.95. So x was 30. N was 120. We had 0.95 as our confidence level. And we go down to calculate. Now, just a real quick note here. X has to be a whole number, no matter what. So if you have to find x yourself, you might have to round it to get it to be a whole number, right? Because it has to be a whole number. All right, so I'm going to go down to calculate. And there's the answer, 0.17253 and 0.32747. So let me write those in. Okay, so 0.17253, 0.3747, oh, I can't remember now, 32747, that was what it was. And there's our final result. And that's how to use the calculator to find a confidence interval for a proportion. Simple as that. All right, let me give you another example just real quick. down here, we have this one where I have computer output already. See that? So this isn't going to be about the computer output. I just want to show you real quickly how to mimic this output with your calculator if you have enough information. So do you see how the sample proportion is 0.67? Let me write that down. Okay, so p hat is 0.67. Okay, and let's say we know n is, we did know, n is 446. Okay. So then the question becomes, what is x? So let's pretend you don't know it. I know it's in that output, but pretend. Because that would be a great question to ask you anyway if I hid something from you. So if p hat is 0.67 and n was 446, what's x? Well, remember, p hat is x over n. Right? So if that's the case, if p hat is x over n, like this, okay, that means that 0.67 is equal to x over 446, right? Yeah, let me delete this because we've got all that. So if you want to times it by 446, you'll actually figure out, but you have to do it to both sides, right? Because if you do it to the left, you got to do it to the right. So you'll actually figure out, sorry, what your x is. I never finished my sentence. Okay, so there we go. So these would cancel over here, right, and be gone. Right there. So you'll have x is equal to whatever 446 times 0.67 is. Let me grab that. 446, oops, 446 times 0.67. So 298.82. So you'd say x is 298.82. Now I know it's not, but bear with me here. I'm just trying to teach you something real quick. Okay, so you'd say, oh, x is 298.82. Now, but here's the problem. If I go to my calculator and I try to do a confidence interval like that, so if I go stat, tests, and I pick one prop z int, which is letter A, right there. All right, so I say 298.82, enter, and then this was 446, enter, and I wanted, I think, a 95%. Let me double check that. Nope, 94%. 94% confidence interval was this one. So 0.94. And you go down to calculate and press enter. It's going to freak out on you and say, no, 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 you can't do that domain. So quit. The problem is stat tests. There you go. If you hit second alpha A, alpha math, that's right, you're hitting alpha A, that'll get you right to that one if you know what it is. So the problem is the decimal here. It does not like it at all, right? And of course, I know we rounded, but I just wanted you to get the idea. So you have to round it to the nearest whole number, like 299. All right, so then when you run it, go down to calculate, it'll actually do it. There we go. Now it's going to be a tiny bit off because I, of course, rounded the heck out of my sample proportion. It was 0.67. It was 0.6726, blah, blah, blah. So by doing that, I've kind of made it a tiny bit off from these computer outputs, but you get the general idea. Okay? So just a real quick note, you must round up. Must round up. It's actually not up, I should say that. I'm lying to you. You must round. Just normal rounding will work, right? But in this case, it went up because 0.82 would round up to 9. So you've got to round in order to be able to make that work if you're going to use your calculator. All right, I'll see you back here for more videos.